Good evening. I'm Charles Schultz with Schultz Laboratories and Universe Science Center. It's 6 p.m. Eastern Standard Time, and this is the Randomizer for the 2nd of March, 2022. Tonight's subject is going to be heliocentrism. Okay, so what is heliocentrism? If you look back in history, you know that people had a very different view of the solar system, of the Earth, the sky, and the sun back then. And they felt that everything went around the Earth, and that's a geocentric model. Actually, after a few years of studying and thinking and debating about it, they came to a better model. We'll get to that in just a moment. I encourage you to go to schultzlaboratories.com and universesciencecenter.com. Sign up with us, click in, become a member, help support our growth, the addition of new galleries and content and new exhibits. Go to the Universe Science Center, walk through the galleries, put your Oculus on, share it with your friends, have a little fun in there and find out all the interesting things you can study and learn. We're hoping that you'll also sign up for some of our classes. On every Monday at 9 p.m. Eastern Standard Time, we have our Meta World series. Lesson 6, the conclusion, will be finished this coming Monday. And every weeknight at 6 p.m. Eastern Standard Time, we have the Randomizer. Random technical terms selected out of a hat, basically. And we talk about that subject. And we invite you to come and join us. Go to our site, click through, go to the page. Just a few minutes before 6, it will automatically conduct you to the live Zoom meeting, and you can ask your questions, give your suggestions. Give us suggestions also as well about things that you'd like to see on the next shows. We'll see if we can accommodate you. So it's a lot of fun, always something new and technical to talk about. Do become a member or supporter of Schultz Laboratories and Universe Science Center, and we're very happy for the people who have done that already, and thank you for that. So let's move to heliocentrism. What does it all mean? Helios was the name of the sun in Greek, and centrism, obviously believing in the center. It's pretty self-descriptive. Heliocentrism is the idea that the sun is the center of everything instead of the earth. When we look at the old writings and notes of Ptolemy, the astronomer who was in Egypt many years ago, a contemporary of Cleopatra, Ptolemy had a theory that the planets moved around the sun in a very specific way. Now, around the Earth. What was the difference? In times past, the sky was the calendar, and we looked at the positions of the sun and the moon and the stars, and we figured out where the beginning of harvest, the beginning of planting had to be. It was basically a tool that allowed us to predict when the Nile Valley would flood and it was time to plant, or when the harvest was nigh and you had to be ready for it. So the sky was our calendar, and everybody thought that everything went around the Earth. The Earth was the center of the universe. So the geocentric model was the dominant model, and even though the planets moved around in odd ways, they figured that there was a set of curves. In this case, Ptolemy decided to call them epicycles, curves that look like a curly cord going around and around, rather than a simple oval or circle. Every planet seemed to go through this strange motion, and they were able to use this series of epicycles to make pretty accurate predictions about where the planets would be in the sky at any given time. The issue was people had questions, and let's face it, everything seems to always fall to the simplest solution, not the complicated solution. So why would that movement be so complex? Well, as it turned out, other astronomers, such as Copernicus, looked at these models and thought that couldn't possibly be right. And it took Galileo, who constructed a crude telescope, observing the moons of Jupiter, to once and for all have an example very clearly that the planets did not go around the Earth. The sun did not go around the Earth. It was the other way around. The moons of Jupiter, and the 4 brightest ones, were the only ones you could see with a telescope in those days. You can't see them with the naked eye. Those moons of Jupiter are named in honor of Galileo. They're called the Galilean moons of Jupiter, the 4 largest ones. As it turns out, he was able to show and publish in his writings that the Earth was not the center of the universe, that the sun appeared to be the center of the universe, and that the Earth was simply one of the planets going around the sun. Of course, then the Inquisition arrested him, and they tried to make him recant, and he was forced under house arrest for the rest of his life, about a decade, and was asked to renege or recant on his statements about the Earth not being the center of the universe. It was a big religious controversy. And as it happens, his writings already been published, and other people picked up on them and could see for themselves the fact of the matter. Now, this theory does very well, up to a point. If you're in another solar system, the heliocentric theory that we use wouldn't work. Our planet and our sun and our moon have nothing to do with other solar systems. So heliocentrism only works within a given solar system. Now, other solar systems have a star in the middle or sometimes multiple stars, and let's talk about that briefly. If you have more than one star in a solar system, there are two distinct ways it can happen. The two stars can be far enough apart from each other, they orbit each other slowly, and 1/5 of the distance is the limit of where planets could form around each of the individual stars, 1/5 of the distance. So you could have two tiny solar systems orbiting each other in one larger solar system. The other way this could work is if the two stars were very close together and orbited each other in a couple of days or so, and your planet was far enough away that they would act as one star. Now here's the thing, the lumps and bumps of the gravity fields are not smooth like they would be for a single star. So there's a certain distance your planet would have to be for those lumps and bumps to smooth out and produce a stable orbit. So it's unlikely that a planet that is in a double star system where both of the stars are the center would remain stable very well, or that they would be warm enough for life. And incidentally, it's thought that early in the history of our solar system, instead of one sun, we had two smaller stars that collided with each other and formed one sun. We don't know if that's true, but there seems to be some evidence to that. The sun rings like a bell in liquid, the droplet moves, and so that's one of the signals that it was in a large collision at some point in the past. But that being said, we now know that every solar system has its own heliocentrism. What about the center of the galaxy? So a galaxy is basically a flat disk in almost every case. It looks like a fried egg more or less. You have a football oblong center or a circular center. You have a flat circular or spiral structure with a few or many arms. And you can see very clearly when you look at a galaxy where the center is. Some galaxies are irregular, the results of collisions of a couple of galaxies. And it's a little tougher to figure out, but there still is a center of mass that everything's orbiting around. So when we look at our galaxy, we see the center. We can see it very clearly without any specialty instruments. And in the center of most galaxies is a very large and massive black hole. So this is where everything is centered. Everything orbits that black hole in that galaxy. Now, here's an interesting thing. If you look at the movements of planets in a solar system, you find that the planets that are close to the star move very quickly, and the planets that are farther out from the star move much more slowly. So there's a very simple rule of gravitation, and the speed of an orbit is determined by how massive the star is and how far away you are from it. The closer you are, the faster you're going to move. The farther out you are, the slower you're going to move. Interesting thing, for galaxies, this isn't necessarily true. When we look at a galaxy, we see what looks like a whirlpool in many cases. And we know that something way out at the edge of the galaxy should be moving very slowly, and something farther in should be moving faster, and something very near the center should really be booking it, should really be moving. We find that this isn't true, and there's a reason for that. Remember, you might have heard when I was speaking earlier on one of my earlier talks, if you had a hollow planet, the gravity inside that planet would be zero inside that void. And the reason for this is the fields for all the mass, the gravity fields cancel each other out with equal pulls, and so you weigh nothing in the middle of a planet or inside a hollow planet. This is because the mass is all out here rather than in the center. Well, what happens in a galaxy? There's the change in orbital speed, and we look at it and we measure it, we find it isn't uniformly changing to slower the farther out you go, and it's because of dark matter. So dark matter is an invisible, ghostly material. If you add up all the mass you see in a galaxy, the glowing stuff like stars, the planets, the gas clouds and dust clouds, you only find about 10% of the matter that should be there to account for that movement. It turns out that some of that mass is scattered out in the halo or around the galaxy, and it pulls back and it slows the changing in orbital speed. So the dark matter acts almost as a drag or repulsion and spreads out the gravitational orbital speed force. It slows down the orbit so that they're all almost uniform. And so this invisible substance penetrates it like a ghost, can't be seen, and it's like a cloud. And that slows down and changes the orbits of all the bodies in a galaxy. Now, one thing you will find, like I said, there's a massive black hole in the center of the galaxy, and things will orbit it quite rapidly. But as you go out, the differences do not match normal gravitational rules, and dark matter is the reason. And we look through the universe, we can see that there must be an awful lot of dark matter. Just about every galaxy has dark matter in it. Now, here's another thing. What about the center of the universe? Now we're in different territory, and there's a reason why you can't point to the center of the universe. Imagine a balloon, and you're going to blow it up. And let's say the balloon is tiny as a point. And you blow in the balloon, and it gets larger. Now imagine we paint dots all over the balloon with a marker to represent the galaxies. And as we blow the balloon up, all the galaxies expand away from each other. If you were standing on one of the dots, you'd see the other dots are all running away from you as the balloon expands and stretches. When we look out into space, we can see that every galaxy out there is expanding away from us at a uniform speed, pretty much. Everyone feels as if they're standing at the center and everything is running away from them. If we look out among the galaxies, we find that everything at a certain distance is moving so fast, it's at the speed of light. You can't see anything beyond there. You can't even see it. So, why? Well, why can't we find the center? How is it blowing up everywhere at once? The answer is simple. The direction of the center of the galaxy isn't anywhere in the sky, it's in the center of the balloon. So if I blow up a balloon, or if I have a ball, the center is inside. It's not on the skin where the galaxies are. Now, our universe is not three-dimensional, it's four-dimensional. And one of the dimensions is the direction that all space-time is expanding. That fourth dimension is literally the direction backwards where the Big Bang, the center of the universe, is. We've expanded away from it, and you cannot reach it anymore. Nobody standing on the outside of a balloon can reach the center of the balloon. So, this expansion has taken, 13.8 billion years. Our sun goes around our galaxy in an orbit, and it takes 250 million years to go around the center of our galaxy. So every billion years is just 4 orbits around the galaxy. Since we know our Earth is only 4.6 billion years old, less than 5 billion years, and the same for the sun, then that's less than 5 billion years, 4 orbits per billion. There's less than 20 orbits that our sun has made around our galaxy, the Milky Way, since it was first formed. So we know how many orbits it's made, and we know that other stars farther in should have been orbiting faster. They don't orbit that much differently. So the dark matter is the explanation. Now, we know something about dimensions. There are names for the directions on our dimensions. If you took geometry in high school, you know about number lines. And the X number line, the numbers get higher in one direction and lower in the other direction. And the Y number line and the Z number line. If you have all 3 of these dimensions, we have names for the directions you can travel in those dimensions. So the X direction is like right and left. And the Y direction is like up and down. And the Z direction is like forwards and backwards. Here's the trick. The other direction, the 4th dimension, has names also. And they are ana and kata, meaning the equivalent of up and down, but in 4 space. So if you really wanted to explain this, you know that the balloon and all the galaxies on it, the space-time, is blowing up like a balloon. It's expanding in the Ana direction, away from the Big Bang, the center of the universe. And the Big Bang is in the Kata direction, downhill, back to the point. You can't see it, you can't reach it, you can't touch it. It's in a direction you can't reach. And if you could reach your arm in that direction, it would seem to vanish as you pointed in this mystical fourth direction. Don't do this at home. So this should clear up a little bit. You know that the past is in the kata direction, the future is in the ana direction. That's the way space is expanding. So interesting things to think about. You can't reach the center of the universe. It's in the wrong direction. It's outside of space and time. It's backwards in time. So, heliocentrism, the theory that everything revolves around the sun. It's a good theory. It lasted very well. It works only in a solar system. Outside in the galaxy, well, the galaxy is a core and we're all going around it. And outside in the universe in general, we're expanding outward from the center of the universe, and you can't reach it and you can't see it. So I hope that's been helpful. I have a quote for you also. And above all things, have fervent love for one another, for love will cover a multitude of sins. 1 Peter 4:8. Think about that. Be nice to people. Don't be a jerk. Don't be mean to people. Be helpful. Be happy. You never know what sort of battle they're fighting or what they're going through in their lives. Be kind to them. It costs nothing to smile. And it says it'll cover a multitude of sins. So be loving to people. Be good neighbors to people. Have a good life. Thank you for watching, and I hope you have a wonderful evening. Make the world a better place. I'm Charles Schultz, the Randomizer. Thank you.